Okay, we've got two more experimental designs to talk about, pretty much covering all the experimental designs you might run into. Well, the easy ones anyway. So, randomized block design and matched pairs design. So the randomized block design involves taking your subjects, dividing them into two groups, or more groups, based on a possible explanatory variable. So this is not random here. So here we're trying to determine the effectiveness of two different medications for fever control, treatment 1, treatment 2. So this could once again be the same thing we use to treat headaches, Tylenol and Aleve, because they also, besides getting rid of headache, they also control fever. So we take our fever sufferers, I don't know where you find them, but I guess you'd find a way. And you take the men and women, put them in two different groups, and then apply the two treatments. Here's where the random assignment comes. So you pick 300 of these people at random, give them treatment 1, the rest of them get treatment 2. Same thing here, randomly choose 300. They get treatment 1, the rest get treatment 2. That's random. And then we're going to compare the effectiveness of the two treatments. Maybe it's the time or the amount the fever gets reduced, or how long it takes or how fast it's reduced. I think what I would take would be wait 1 hour and take their temperature again and see how much the fever went down. That would be an easy thing to do. And so we look at that, compare, so fever reduction, I think. Compare fever reduction. You can actually compare the actual degrees that it fell for men and for women, and then you can compare whether the men and women had similar responses to the treatment. So if you're a drug company, you like to be able to tell people that my medication is equally effective for men and women, or you could say this is specially designed for men or specially designed for women because I see a more effect on fever reduction for either men or women. And there you go. So you'd be able to report something. Now, otherwise, if you didn't break them into groups, we'll talk about that in a minute. It says treatments are, okay. Why divide it to men and women? Well, so it's possible the medication you're using or the comparison of the treatments you're using, that aspirin works better for men and aspirin works less well for women. So if we combine those two groups into one group, it would look like both treatments are equally effective. So that would mean that you wouldn't care what you take, Aleve or aspirin, because if the men do better with aspirin and the women do better with Aleve, when you combine them in two groups and look at how long it took the fever to get reduced over the groups that were combined, you wouldn't see a difference. So the worry here is that maybe men and women favor different treatments. So men do better with one and women do better with two. So combined, the treatments would appear about the same. Okay. And what about control groups? Well, hey, they have a fever. We're not going to give anybody nothing because that's going to take a long time for the fever to go down. So we're just using the treatments themselves to form a control. Everything else besides the treatments, 1 or 2, would be the same for all the men. So we'd anticipate, well, except we randomly assign it and try to control for things that they might have come in with, like how much fever did they have, why do they have a fever, all that kind of stuff that we didn't measure by randomly assigning the treatment to 300 men. Hopefully you've mixed up all those other variables that might be causing the fever not to go down or go down quickly. And so the two groups look about the same in terms of what would happen if they receive the same treatment. They should behave about the same. So now they see different treatments. We can see the impact of the treatments. So that takes the place of control here. We use treatment 2 serves as a control for treatment 1 and vice versa. Yeah, I'll say that. So the the treatments serve, can't spell here, serve as controls. So either you can think of treatment 1 as being a control and treatment 2 as being an experiment, or vice versa. So there actually is a control group. It's one of the treatment groups. You can think of it as a control group. So over here is match pairs. Match pairs involves matching subjects up according to some other explanatory variable. So here we have not random here. So it's like a block design, except the blocks are size 2. That's why it's pairs. A block design, blocks of size 2. So you can have a matched pairs design where an individual serves as its own pair. So you were testing sunscreen, 2 different kinds of sunscreen. You can put 2 stripes of sunscreen on your one arm, go out in the sun, come back and see which one worked better. That would be a matched pair design because the explanatory variable that you're controlling for is the skin type. But since you have the same skin type in the 2 places, then when you look to see which one gets sunburned, you know which sunscreen works better. Otherwise, if you just put a stripe on one person and a stripe on the other, the 2 types, if one person had fairer skin than the other, probably wouldn't matter what sunscreen you used. The fairer skinned person is going to burn quicker than the less fair skinned person. It's going to look like the sunscreen is working better on the less fair skin and worse on the fair skin. Really, it was just the type of skin that made the difficulty. So we wanted to keep that from happening. So we want to pair things up. Here are 6 students. We're wondering the 2 treatments are the treatments are 2 different PE programs that you might try. So one of them, the PE programs might be just playing sports, softball, basketball, whatever, that's PE. And the other one might be working out in a weight room and maybe running on a treadmill. So there'll be 2 different treatments, 2 different PE programs for students. We're wondering how we can get them to do more push-ups. You know, no one can do push-ups anymore. Well, mostly. A lot of people can't do push-ups. So they take the 6 students. They ask them to do push-ups. They found 2 students could do no push-ups. They anticipated that. 2 students could do between 1 and 9 push-ups. And 2 students could do 10 or more push-ups. So we divided them up into the least fit, the medium fit, and the most fit in three groups of size 2, because it's a matched pairs design. And then you take the students here. We randomly assign these 2 students to treatment 1 and treatment 2. So one of the PE programs. So one of them goes into this just playing sports, and the other one goes into the weight room. But it's randomly assigned, randomly assigned, randomly assigned. And then we compare the number of push-ups they can do at the end of the day. Well, at the end of the day, at the end of the PE program. So maybe the PE program goes for 2 months. And you compare after 2 months how many push-ups the students can do. So if they started off at 0, they went through 2 different exercise programs. At the end, we'll see how many they can do. Maybe we subtract number of push-ups from treatment 1 and number of push-ups from treatment 2, see which one is larger. So if we see a treatment 1 group minus treatment 2 group as a positive number, then more push-ups for treatment 1, that means treatment 1 worked better. We do that across the board, look to see if they're all positive, all negative, whatever. The students were randomly assigned, so we're not accidentally putting the stronger student in treatment 1 or 2. We're going to randomly flip them. With 0 push-ups, we don't know who's who. With these, we know, but that's our group, so we just randomly assign it and hope for the best. Same thing here. It says Y match. Well, since we get to compare the different groups based on how fit they are, with a fitness level is not going to enter into the comparison. So this is just to control for fitness at the start. So you want to take equally fit people. Y random there still will be differences between them. We're going to try to not consistently assign treatment 1 or 2 to the least fit person. Try to not consistently assign treatment 1 or 2 to the least fit person because they'd be at a disadvantage then in the push-ups they could do at the end of the day, and that wouldn't be fair. The explanatory variable is PE program. Which one did you get put into? The response is number of push-ups you can do at the end. And control, we don't need a control group either because the treatments serve as their own control. We don't want to compare the two possible treatments to doing nothing. Doing nothing is not going to make you stronger, you would think. So we just want to compare the two kinds of treatments. When you're doing that, you don't need a control group. Ordinarily, when you have a control group, that's because you have something that you're doing ordinarily. You want to compare what you're doing now to something new. So we could do that here. We could say treatment 1 is a typical PE program that doesn't involve any weight room activity, and treatment 2 adds the weight room activity. Then treatment 1 would be a control group, and treatment 2 would be the experimental group, and you could see if it did anything to improve things. We still assign things randomly. We still compare push-ups at the end. We still want to take the least fit people to begin with together, medium fit and overfit together, so the fitness level wasn't responsible for the results. If we didn't combine them, if we put the students all together and just put treatment 1 and treatment 2, we might accidentally put all the unfit people into treatment 1 and all the more fit people into treatment 2. We don't want to do that. So here, the more fit people get both treatments, the medium fit people get both treatments, and the not fit people get both treatments. So that's why we need the groups. Why match them? Why random? We don't want to consistently. I think we're in business. Explanatory PE program, response number, push-ups, control. In this case, treatment serve as their own control. And I think that that's the end of chapter 1, which is exciting to me because it has lots of sections, and we finally finished it off. Yay. I will see you in chapter 2 as it comes up.